Hey students, in this video I'm going to go over the notes of 7.3, which are explaining how to calculate the horizontal asymptote for rational functions, whether you're given standard form or factored form. So I just want to point out here, these are examples that are standard form, but if you were to have factored form, I'm just going to show you here. If we turn this into two factors, we'll have x plus 7, x minus 7, and x plus 7 on the denominator. So whether you have standard form or factored form, you can still calculate the rules that you're going to see on this video. The three rules that you need to memorize or understand is when the degree of the numerator is greater than the degree of the denominator. And in case you forgot what a degree is, the degree is the highest exponent that you see on the expression. So you're going to compare the highest exponents that you see on the expression at the numerator and the expression on the denominator. So this one is the degree of 2. And then this one has an exponent of 1. So this is the degree of 1. When you look at the degrees, the degree on the numerator is 2 versus the degree on the denominator, which is 1. You can conclude that this is top heavy. That's the keywords we're going to use, top heavy, which means that the numerator, the number on the top, is greater than the denominator. So anytime you have the expression of top heavy, or the numerator, the degree of the numerator being greater, we're going to say that there's no horizontal asymptote. There's no asymptote that you're going to see when you graph this in the calculator. And then one way you can see this in factored form as well is whenever you have factors multiplying times each other, this will be x times x, which will create x squared. And then this is just an x on the denominator. So that also shows you how the degree on the numerator versus the degree on the denominator can also be seen as top heavy. Okay, so the next rule that you want to remember is the degree of the numerator being less than the degree of the denominator. So here, whenever we look at this, we're going to compare the degree on the numerator, which is 1 on this case, and then the degree on the denominator, which is 2. So this one, we say that it's bottom heavy. And even if we have the factored form, which will be like this, I'm going to just again explain how by looking, the top only has 1x, and then the bottom has x times x, which will create that x square. So it shows the bottom heavy on this one. That will be the keyword we're going to go by. Bottom heavy because the denominator, the bottom, is bigger. So for this scenario, we're going to say that the horizontal asymptote is y equals 0. And what I want to do is show you the visuals of this. So if we were to graph the example on the top, the example of top heavy, this is how it would look. It would just be a line. And if I zoom out, you notice that it's just still a line. So it's never going to stop being a line, a linear function technically. So there's no horizontal asymptote for this. The second example we had seen, which was bottom heavy, this is what it looks like if we graph the bottom heavy example. And it shows that we have an asymptote right here going through the x-axis. So if I type y equals 0, this looks like a bolded black line on the x-axis, which is exactly where the asymptote is for that one. So when we look at the last example, this is whenever we have a balanced scenario. We have the degree of the numerator being equal or the same as the degree of the denominator. We are going to have to calculate the asymptote. So for example, right here, the degree is 2. And then here, the degree is 2. So because they're the same, we are going to look at the leading coefficients. So we're going to look at the leading coefficient of the numerator. We're going to put it over the leading coefficient of the denominator. And that's going to create a fraction that will represent where the horizontal asymptote is. So the first example here is the leading coefficient, which is again in the front, the leader, and it's a number in the next to the variable. There's no number, so it's a 1. And down here we have a 3 as the leading coefficient. And we can just say LC to abbreviate it. So the leading coefficient here is 3. So 1 for the top, 3 for the bottom, which leaves you as 1/3. This means that if we were to graph it, when y equals 1/3, we're going to have that horizontal asymptote happening. So a visual for this would be this graph right here. If we notice, this graph is going above the x-axis because the asymptote is a little higher than the x-axis, which results again in 1/3 being what we calculated. And if you notice, now it has a visual of how that asymptote is at 1/3, and it just works out. So that's what you're doing in this assignment. You are identifying horizontal asymptotes, and it's all based on the 3 cases, whether you have top heavy, bottom heavy, or a balanced scenario with the degrees. In the back of the notes, there was some examples for you to practice, and I'll just go over the first 3 so you can see how to identify these. So you look at the degree again, and the degree for the top here is 2. The degree for the denominator here is 2. So because they're both the same number, we're going to say it's balanced. So in that case is when we had to write the equation using the leading coefficients. So leading coefficient of the numerator is 3 over the leading coefficient of the denominator, which is 1. That's 3 over 1, which results in 3. So this means that if we were to graph it when y equals 3, you'll have that asymptote. So y equals 3 is the asymptote, the horizontal asymptote for this example. The next one right here, we have a degree of 1, and this is the degree of 2. So the exponents, again, 1 and 2. This is higher or greater on the bottom, so this is bottom heavy, according to our keywords to remember this. And when it's bottom heavy, we said that the asymptote was going to be always y equals 0, which means that we are going to graph and then have an asymptote on the x-axis. So on this one, it says to circle the functions that have that asymptote, so we're going to circle that function. And the next example is showing you a degree on the numerator, which is equals 3, and degree on the denominator, which is equal to 2. This is top heavy because the top number is greater. And when it's top heavy, we saw the example that there was going to be no horizontal asymptote. So on this one, it's asking you to box the functions that have no horizontal asymptote. So we're going to do that to this one. And that's how you continue practicing with this handout behind your notes. I hope this video helps you.